Fundamentals. This week we are talking about data virtualization with PolyBase and SQL Server 2022 with the man of the hour, Kevin Feasel. Today is August 30th, 2022. In the top right-hand corner of the screen, you should be able to see all the leaders of the DBA Fundamentals group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If for any reason you need to get hold of us, always reach out to us on Twitter. Below that, you'll see the many ways you can reach out to DBA Fundamentals on social media. The easiest way would be Meetup, where you've probably found us today for this actual group, this presentation. Below that is our website, dbafund.org, where we have all of our past presentations as well as links to our upcoming presentations so you can sign up for them. Below that, you will see dbafundtube.com. That is our version of YouTube. It has all of our past presentations so that you can watch them and also get notifications whenever we do put today's presentation out there. So be sure to sign up for and like us on DBA FunTube so you can get notifications whenever we are actually have posted the latest presentation. Below that, you'll notice we have our links to Twitter, where we're DBA Fund, our Slack channel, and our LinkedIn group as well, where we post different things. As always, today's session is going to be recorded, and usually it'll be available within 1 to 2 days. As I said earlier, be sure to check us out on dbafund.com. As was just shown off, be sure to remember to turn off your video and mute yourself so that we don't interrupt the presentation and all of its goodness. Also, be sure to type any of your questions you have into the chat window, and we'll be monitoring that so that Kevin Feasel will have all kinds of good questions to come up with and answer, sometimes in insane ways, but it is an answer. As always, we have the bio for Kevin Feasel, and with that, I turn it over to Kevin himself.
All right. Thank you. Thank you, sir. Didn't want to confuse everybody by saying thank you, Kevin. Although sometimes I do refer to myself in the third person, kind of like Ricky Henderson. But we're not talking about the greatest base deal of all time. We're talking about data virtualization and SQL Server. And if you do have questions or comments, or you think Lou Brock was the best, go ahead, put that in chat now. It was still Ricky, though. But let's talk data virtualization. My name is Kevin Feasel. I run a predictive analytics team out of Durham, North Carolina. I have a blog called Curated SQL, where every day I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So you can find that curatedsql.com. I also happen to have a book that is kind of relevant to this story, and that is PolyBase Revealed. Now, PolyBase Revealed was released after SQL Server 2019, and it was the first book that was specific to PolyBase. It covered what I refer to as version 1 and version 2 of PolyBase. Those are kind of terms that I came up with. Now, if you are one of the many, many people who bought this, by which I mean there were dozens of people who bought this, thank you for that. But also let me say that with SQL Server 2022, a lot of the information in that book is now going to be, go ahead and scratch that out because it's gone. So let's talk about what data virtualization looks like as we get into 2022, see what the changes look like, and see what we can do with SQL Server 2022 specifically. We'll install, configure, and work through a couple of business scenarios with the product. There's a lot of content in here, so if you have questions, please get them in chat, and I'll answer them as I can, but I probably will not be breathing through the rest of this session, so just understand that in mind. If I'm speaking too fast for you, in the ellipsis, the more ... you can turn on captions, and it does a reasonable job of translating the words that come out of my mouth to text. So that may help with the torrent of information I'm going to be throwing your way. As we get started, though, let's do a little historical review. Very briefly, PolyBase is Microsoft's technology for covering 2 use cases. Prior to 2022, it covered 3 use cases. So it cheekily scratched out the 3rd use case, which is no longer a use case for PolyBase and SQL Server 2022. Step 1, connect to multiple heterogeneous remote data sources. Meaning, I can connect to a whole bunch of different data sources like Oracle, like Teradata, MongoDB, CosmosDB, Spark, Hadoop clusters, Excel, everything like that. Big data services like Excel. Number 2, data virtualization. Make it look as though all of these different remote sources are local. They are just they're tables exposed in T-SQL that this information, which is actually in a remote Oracle database, is just another table in my SQL Server. Similar to linked servers, except linked servers have that 4-part naming. External tables just have 2-part naming. They are local to the database. It's just that the data is not local to the database. The data is somewhere else in the world. Real brief. PolyBase came out of a Microsoft research project that eventually became a core part of Parallel Data Warehouse. Parallel Data Warehouse Edition married together the notions of Hadoop and SQL Server. PDW became APS, and as I was joking before the recording, I've never been able to afford to look at one, much less own an appliance. My recollection is that they were in the upper 6 digits, lower 7 digits to purchase. And you needed serious workload requirements and serious Hadoop skills, as well as T-SQL skills to make good use of them. But SQL Server 2016 brought PolyBase to the masses. This is where V1 was introduced. And it was also brought into Azure SQL Data Warehouse at the time. Now Azure Synapse Analytics, dedicated SQL pools. PolyBase it was brought into that space there. When I say brought into dedicated SQL pools, the same logic also applies to the serverless SQL pool, but it's where things get real tricky because the term PolyBase means a specific thing, and data virtualization in SQL Server, even though it uses the same structure, may or may not be PolyBase. So if I slip and I use one of the terms interchangeably, and you know that it's not right, please, I beg for forgiveness. So let's come back on premises. 2019, we had a big update to PolyBase. This is where we got Odbc connectivity. This is where we got the ability to connect to more than Hadoop and Azure Blob storage. And then 2022, we're getting some new capabilities and we're losing some capabilities. So let's talk in a little more detail about what that implies. V1 was all about Hadoop. It was really connecting to the Hadoop distributed file system, HDFS. As a happy historical accident, we also got the ability to connect to Azure Blob Storage because Azure Blob Storage actually has a web HDFS interface called WASB. Well, we were able to take advantage of that WASB interface and read from Azure Blob Storage. 2019 comes out. We get plenty of other data sources. SQL Server, Oracle, MongoDB, Teradata. Those drivers were built in. We could connect to CosmosDB using the Mongo API. We could use as well any Odbc connector. A lot of different examples. I've got examples galore in the demos that we could look at. But basically, if you had an Odbc driver, PolyBase might work with it. That was always a little roll of the dice. Sometimes you needed to find the right driver that would work with a particular platform. Sometimes it would just work perfectly right off the bat. Quick note, that generic Odbc connector, Windows only. So if you're running SQL Server on Linux and using PolyBase, you were limited to the big 4 at the top. 2022 eliminates V1 support. Hadoop is gone. Also says something about the market as a whole. But we can't connect to HDFS. We can't connect to Azure Blob Storage. However, with 2022, we can connect to Azure Blob Storage. basically V3, or it's not even V3. I gotta stop saying that. Data virtualization in 2022. This is not PolyBase. This is a new set of code that allows you to interact with APIs. As of RC0, we have the ability to connect to Amazon S3, Azure Blob Storage, and Azure Data Lake Storage Gen 2. Gen 1, let's not even talk about Gen 1. But you can connect to Gen 2. You can work with Delta tables, so you can work with that Delta format. All of this is available to us in RC0. There might be additional connectors coming out after RC0, but as of right now, that's what we've got. Brief summary, if you're looking 2016 to 2019 versus 2022, if you're connecting to one of the Odbc sources, as of 2019 and 2022, it's really the same. That is PolyBase, and that's still around. If you want Azure storage, pre-2022, you were using PolyBase with a Java connector. Post-2022, you're using a new data virtualization technology that does not require Java. S3 is brand new. Hadoop, specifically the Cloudera distribution of Hadoop and Hortonworks data platform. So, we're already talking about versions of Hadoop that are 4+ years old. We're talking about cases where this was before Cloudera and Hortonworks combined. What happened was they combined and they released a web-only version of Hadoop that didn't really work effectively with PolyBase. Structurally, it didn't make much sense for them to open up the ports that are necessary for PolyBase to do its thing appropriately. And that's a big part of the reason why Hadoop support is just deprecated. There might be some ability to connect to HDFS in the future, but as of RC0, not in there. Real brief on scale. This is the thing that I slashed out in the 3 great use cases for PolyBase. Well, SQL Server is a classic scale-up technology, meaning I am having some sort of resource constraint. Let's say that it's not the code for once. What can I do to improve my performance? Well, I can add CPU, I can add memory, I can get faster disk. And I add. So I'm scaling up the machine. I get more powerful machines with faster CPU cores. The other option is scale out. And Hadoop or Spark or Kafka or anything else in that Hadoop ecosystem, really good examples of MPP, massive parallel processing. Instead of scaling up, I also have the option to add more of these systems. You can technically scale out SQL Server. It requires a lot of development effort. It requires that you build a lot of the pieces in place. I know that you can. I work at a company that does it. But it does require a lot more effort than hosting one SQL Server instance. And your application has to understand this. Your application has to work within constraints that you develop. So you're building a lot of the coordination logic. By contrast, a tool like Hadoop or Spark, they have built in that coordination logic. Azure Synapse Analytics dedicated SQL pools has built in that coordination logic. But on-premises SQL Server does not have any of that. You're running a machine, and it's siloed. It's kind of living on its own. Prior to SQL Server 2022, PolyBase gave us the hint of this notion of scale out on premises, because you could have multiple SQL Server instances as part of the same PolyBase scale out group. The idea here was that these multiple instances could communicate effectively with the remote sources and pull back, say, partitions of data. If you were connecting to Hadoop, you could talk to each of the data nodes with your SQL servers and have them communicate directly instead of pushing data up through the control node, passing it over, and then bringing it back down. This allowed for more efficient processing because you had more machines working on the same problem. With 2019, you had some limited capacity for scale out, but this was a pretty complex thing. You needed a lot of pieces to work together for it to be effective. And performance wasn't always a fantastic improvement after you left the Hadoop world. So it's been stripped out. It is no longer available in SQL Server 2022. Rest in peace, scale-out groups. Let's see what is available in 2022, though. Let's go to some installation and real quick screenshots, because I don't want to waste a lot of time having us install SQL Server. So we say new standalone installation, and there is one option, the PolyBase query service for external data. This is going to give you PolyBase as well as the data virtualization that is built into SQL Server 2022, whose name I don't even know what the name is. But you check that box, you get it. There is one configuration option, a port range for the PolyBase services. PolyBase does need a certain number of ports open, and by default, it is 16450 through 16460. That's been the case at least since 2019, and I think it goes back to 2016, those exact ports. There are also two Windows level services that are running. One is the PolyBase engine, and that's the brains of the operation. The other is the data movement service, and that's what's going to take data from remote sources and pull it, make it available in SQL Server for the purposes of external querying. So those two services do have to run. They do require at least network service, so you can't use virtual accounts for them. You may notice that, for example, the SQL Server agent and the database engine are NT services. Those are virtual accounts. This is NT Authority Network Service. So it does require more privilege than a virtual account does. But that's all as far as setup goes, or as far as installation goes. Setup's got one more step, and we'll get to that in a moment. Let's compare that to 2019 very briefly. 2019 had two options for PolyBase, and the first one is the PolyBase query service for external data, which is V2. The second one is the Java connector for HDFS data sources. This was your V1, and it does have a swear word in it. And so you do have to install Java if you're going to check that box, if you want that Hadoop and Azure Blob storage connectivity. We also had the concept of scale-out groups. So, you see this question up here completely stripped out from 2022 because scale-out groups are gone. Most people checked this box anyhow. They went with the standalone instances because it was a lot easier to work with. But now we don't have an option. Java was required if you selected the box for PolyBase V1. You had to have a version of Java, and Microsoft did partner with Azure Systems to license their Zulu OpenJDK, and you could install it, you could have it on the box, but then you had to keep Java up to date on your SQL Server instances. Something that I know a lot of companies were not happy with the idea of. The services were the same, and setup was just a little bit more complicated, but not a huge difference. Now, 2022, 2019 doesn't matter. To turn PolyBase on, we run spconfigure and set PolyBase enabled to a value of 1. For 2019 and earlier, Hadoop connectivity, if you installed the V1 bits, required that you set a Hadoop status. Generally, I recommended 7. 7 is the latest version of the Hortonworks data platform that they supported. And really, if you were just using this to connect to Azure Blob Storage, it didn't so much matter which of these you selected, just that it be some value greater than 0 and below 8. 1 through 7 were the only valid values. Frankly, 6 and 7 were the only valid values by the time you get to 2016. All right. We've installed PolyBase. We've enabled it. After you enable it, you got to restart the SQL Server engine as well as the PolyBase data movement and or PolyBase engine and data movement services. And you're raring to go. Well, now if you want to connect to some Odbc source, Built in, we get SQL Server, Oracle, Teradata, MongoDB. You have some other driver you want to use, you've got to install that ODBC driver on your SQL Server instance. And this is only for Windows. So if you have Linux-based SQL Server on Linux, no dice. But you follow those normal installation steps, you get your drivers. It's usually next, drivers installed. Now I want to dive in and talk about the three options or the three external objects that we're going to need to deal with. And they are external data sources, file formats, and tables. So I do have slides about all of this, but I figure, you know what? Let's just dive into some demos for the next half hour or so, and then we'll wrap it up with questions. All right, hopefully this is large enough for everybody to see. If it is not, let me know and I'll bump it up yet another notch. But our starting point, SP configure PolyBase enabled, set the value to 1 and restart the instance. I also am going to turn on an advanced option called allow PolyBase export. This allows you to write in certain circumstances. Those certain circumstances, you're writing to one of the new 2022 sources. So if you're using old pre-2019 or 2019 or earlier PolyBase, you could write to Hadoop, you could write to Azure Blob Storage. If you're using 2022, you can write to Azure Blob Storage, Data Lake Storage, and S3. You cannot write to any of the ODBC sources. So you cannot write to SQL Server, Teradata, Oracle, MongoDB, Cosmos DB, Excel, or whatever. That's read-only. But I've got this on. That way we'll be able to see a scenario where we do some writing. I do have a database called Scratch that I'm going to use for my demos today. And I have a database master key that is some secure key. Hopefully your secure key is slightly better than my some secure key. But whatever I put in here, no matter how secure it is, it's on a video somewhere. So it's not going to be that secure. So let's start with our first example, Azure Blob Storage. Azure Blob Storage, like I mentioned, this is a new connector for 2022. And the way that we're going to work with it is I'll use Scratch and open my master key. I'm going to decrypt it with my secure password. One thing that I do need to point out before we go too much further is I am connected using SQL Authentication to my local instance. SQL Authentication is important here. I have a blog post coming up on this week about 2022 and Windows authentication and data virtualization. The real short version is some things you can do with Windows authentication in data virtualization land. Some things will give you a hard error. And I'll wait until the blog post to give the full rundown. But if you're not on an Active Directory domain, then you probably want to use SQL Authentication. This VM is not on an AD domain. I'm using SQL Authentication so that I can show you the demo without getting a severity 20 error that is going to kill my session. So let's avoid that today. So we're going to use SQL Authentication across the board. I do have an Azure Storage credential. Azure Storage credential is a database scoped credential, and that includes my identity and secret. With Blob Storage, I have two options. Option number one is I can use the account name as the identity, and I can use my key, the Azure Blob Storage key, as my secret. Pre-2022, that was the only way I could do this. With 2022, I can use shared access signatures or SAS tokens. SAS token is something that you create pretty easily within Azure Storage Explorer or even within the Azure portal. And it allows you to narrowly tailor the exact rights that you want to give for a service. You can also set the amount of time that it's eligible for. So it may be eligible for the next 90 days, and then it needs to get a new SAS token. Maybe for the next 90 years if you just don't want to deal with it ever again. You can narrow things down by IP address or IP range. You've got a lot of control over what exactly that SAS token provides in terms of security access. I do highly recommend using SAS tokens for interaction with blob storage and data lake storage, but you can use the access keys if you wish. The next step is to create an external data source. My external data source needs to point somewhere. An external data source is just a pointer to an outside resource. I'm going to point in this case to Azure Blob Storage. I know that because the protocol. So this is how data virtualization and SQL Server 2022 knows what the thing is on the other side that it's talking to, because the protocol says ABS, Azure Blob Storage. And I'm going to connect to my account, CS PolyBase Blob. I'm going to connect to the container, NCPop. And I'm going to use the credential, Azure Storage credential. So I can run this. Ran successfully. That's part one. Part two is I need an external file format. External file formats basically say, this is the way that I am going to communicate with the outside world. This is the file structure. If I'm reading from Azure Blob Storage or from S3 or something, there are 4 major formats that are supported, 2 of which are really relevant, a third of which is still somewhat relevant. The 2 really relevant, delimited text, which I have right here, and the other one is Parquet. The third, which is kind of relevant, is ORC, optimized row columnar, which has some support. Some parts are supported, some parts are not. I'll get to a demo later on where we show what's not supported. And the fourth is RC file, which is kind of an old format for Hadoop. I don't recommend you use it today because ORC and Parquet are drastically better than RC file in every way. So we create a file format, and this one doesn't have a header. So actually I need to fix that script. I'll check that in later. I'm going to use a field terminator of comma and UTF-8 as the encoding. Here I've got a version with a header where it says the first row is 2. So this is a thing that's new in 2022, this first row. And essentially it's going to say, hey, I have 10 rows of pre-file gibberish that I just want you to ignore. And it will helpfully ignore those and start on the 11th row. In my case, I have 1 row of headers that it can helpfully ignore, and we're going to ignore it. Last thing, what about support for XML? XML is not supported as an external file format in this case. You could, what could you do? Not very much with PolyBase. You'd have to translate it to something else that is supported. Even JSON. JSON is kind of sort of supported in Azure Synapse Analytics, but even that's a bit of a hack. And I haven't tried the JSON hack in SQL Server 2022. So generally, this is intended for Parquet and for flat files. The last thing we've got is an external table. So we have a North Carolina population table. This table goes from data source Azure NCPop Blob. The location inside Azure Blob Storage is NCPop is the container. There's a folder census. There's a file North Carolina population.csv. It does have a header, so we're going to start in the second row. And I've got this notion of rejection. So let's take a quick look at this external table and see what rejection does for us. If I run this query, there are 13,611 rows in the file. If I open up the file in Notepad++, 13,611. That includes a header, and it includes 3 rows that are not quite in this format. So this format is T-SQL. SQL Server requires structured data. PolyBase and data virtualization is no different. We need structured data being sent to us. So we have to define data types, names, data lengths, nullability. We need that information before we can display it as external tables. So even though it's coming from a system where we don't have those structure checks necessarily, we need it coming in. So I write this query, and By running, we get some errors. And these errors are quite helpful, it turns out. This is sort of unlike common errors in SQL Server, but I need to bump that down just a notch so we can see the whole error in Azure Data Studio. Bulk load data conversion error. Type mismatch or invalid character for row 1672, column 8, population, 8732, column 8, 10472, column 8. Basically, what that's saying is, hey, while we were trying to read this file and turn it into this structure, the population column is not actually an integer. So population is supposed to be an int, but it's not. Now, if I go to the results, because I had fewer than 5 errors, I get my result set back. And it shows the 13,607 rows that did have proper values. The 3 rows that it complained about have a population that's a letter A. The data source that I grabbed it from, they used the letter A instead of some indicator of unknown or null or something. And instead of me cleaning that up manually, I could reject the row because I know that that's not a valid population to begin with. So that's what rejection can do for you. Once that external table is available, it is, for our purposes, a table. So I can query North Carolina population. I can use a where clause. The year is 2017. The population type is pop estimate, on and on. I can order by. I can just treat it like a normal table at this point. Now, I do get these error messages. This, by the way, is new to 2022. Prior to 2022, it would be silent until failure. If you hit the rejection threshold, it would just fail the query and you would get no results. Here, it tells you exactly what the errors are. Now, I haven't tried this with, say, a .NET application to see if these errors are going to cause a major failure. But considering that they are level 16 errors, I get the feeling that some apps would break if they upgraded 2022 and they were working off of external tables that had rejected rows. But I'd need to test more to find out for sure. Maybe the driver handles it for us, that if you get one of the latest Microsoft Odbc drivers for SQL Server, maybe that handles it. Maybe. Anyhow, I perform this filtering. I get back my results. These are the largest populations based off of census data. I think that was estimates from 2017. Yeah, the year 2017. I can create local tables. So this is an actual local table, and insert some data in here, insert some data into this table, and basically say, in North Carolina, there are 2 combinations of cities. You have the triangle, which is where I live, Raleigh, Durham, Chapel Hill. You have the triad, which is Greensboro, Winston-Salem, and High Point. And comparing the 2, we have our results. So we can see the population center. Basically, I have my external table. I have joined it to my SQL Server table, and I just get my data. You know, it's all very smooth as far as I want to write T-SQL. There's pretty much no T-SQL that will not work with external tables. If it's the type of thing that you can do in a select statement, you can do it here. The one thing that I will warn you about, when we're using something like Azure Blob Storage, we are going to read the whole data, read the whole file in. We're going to take that file, stream it over to SQL Server. Think of loading it into a temp table. I say think of because it doesn't always load into a temp table, but we're streaming it over, we're loading it over here, and then we're writing a T-SQL statement against the data that's in this temp table. If you have 500 million rows over here, you're going to be sending a lot of data over. That's why I don't necessarily recommend this for enormous data lakes, where you want to have the entire data lake accessible externally through SQL Server on premises. Could you technically do it? Yeah, just expect to wait a little while. Speaking of data lakes, let's look at our data lake storage example. We once again open up the master key and my data lake credential. I've already created one, but I do want to call out, when you do create a shared access signature token, If you copy it from the portal, it will give you it in query string format where it has a question mark at the beginning. You want to take that question mark off and start with the SV equals and then have your shared access signature token in there. So just to make sure you get the right one. Otherwise, you may get an error and not understand what's going on with the shared access signature. I've got a data lake. I know it's a data lake because ADLS format, bdadatalakedfs.core.windows.net. Also the fact that it's dfs.core.windows.net. In Synapse, in Mars Farming Curated. So I'm going to create that external data source. I'm going to create a Parquet file format. Parquet, if you're not familiar with it, is a columnar data storage format. If you're familiar with column store indexes, think of it as file-based column store indexes. You're storing data in columns. You're doing a lot of compression on those columns, and it's really intended for fast aggregations of small numbers of columns. So I have a fact table that I may store all the data in Parquet format. I'm going to pull up that fact table. I'm going to perform my aggregations and get back my results. It's not intended for a lot of point lookups. It's not intended for a lot of really wide scans. Performance can suffer on those types of queries. But for warehousing type queries, Parquet is a great format, which is why you'll very often find it in data lakes. And over in my data lake, I have a series of folders, one of which is called Errability Score. This is some artificially generated data that I've got from Mars 100 years in the future. And we're going to read in the data from January 2116. So let's run this. You'll notice that the process to create an external data source is the same. Location and credential is all you need. The external file format, there's actually less stuff involved with Parquet than there was with delimited file. And one of the reasons why is Parquet includes header information. Parquet includes data types. It includes data sizes, data lengths. It includes a lot of metadata information built into the file itself that SQL Server and other data readers can take advantage of. So you don't need to tell it skip the first row because the first row is headers. Parquet has the headers separate from the data itself. It's a really well put together data format. Our external table reads from Mars Farming data source, hits the Parquet files in Parquet format, and I can run my count star on Errability Score and see that there are approximately 40 million rows in that data set. There are a series of Parquet files in the folder, adding up to approximately 40 million rows. I can grab a few rows from there, and we can see that the data structure is very simple. It's just a plot ID, a report date and time, and an Errability Score. But I can write queries against that data. So for example, plot an average and group by plots. So I can see what the average Errability Score is for each plot in the data set. I can see what the average Errability Score is across all plots for a given day. So for each day in the month of January 2116, what was the average Errability Score across the board? And we see my minor changes over time. So data lake storage, very similar in how we set it up to Azure Blob storage. Now we're going to have some differences because we're going to connect to a SQL Server instance. We're no longer using the new data virtualization that's in 2022. We're using PolyBase that came out in 2019. And if I pop over here, I have two instances. This is my primary instance. This is a named instance somewhere. And somewhere has a database called Forensic Accounting. So Forensic Accounting has a few tables on it. And we're going to be interested in accessing data from at least one of these tables. But if I pop over to Scratch, where I've got right now, if I refresh, Azure Data Studio does a pretty good job of telling me external tables versus non-external tables. I actually like this format better than what Management Studio does. Management Studio has a folder inside tables that says external tables. Here it says, hey, errorability score is a table. I mean, it's got columns, it's got data types. You can query it, select star from dbo.errability score. It just happens to be external. It just happens to not live in this database. But otherwise, it's a table. So I've got a couple of external tables. I've got over here in external resources, some file formats, and I've got some data sources. Now, I had a couple beforehand, but we did add Azure NC Pop Blob. We added Mars Farming. So, we've got some data in here. But I want to connect and I want to read SQL Server. In order to do that, I do need database scope credential with SQL authenticated login details. So I created a login over on my somewhere instance called PolyBase user. And I gave it a password of some password. And I've got this database scope credential created. I'm going to create an external data source that points to the somewhere named instance. So the way that we create an external data source needs a login, needs a location, and it may need additional stuff. So we have a couple of things here that we did not have in the prior demo. We do have a location, and it uses the protocol SQL Server because it's going to connect using the SQL Server driver. And I give it a name. If I just give it the name, if I give it that name, that's my server name, it's going to try to connect to the server name on port 1433. And, well, it's going to connect to itself. This is an arbitrary name because I've created connection options. Connection options say, hey, your server, don't connect to 1433 on this port. Instead, connect to this named instance and use these credentials. So unless you've created this login and this password and granted it the ability to access the server, we may have a problem. But I have done that. And so I'm going to connect using the PolyBase user account. I will turn on pushdown. The idea of pushdown is I've written a T-SQL query here, and I'm using SQL Server over here. Why not just take the contents of this operation and whenever possible, send it over to this side, filter in a where clause. So if I say where employee ID equals 7, instead of pulling all of the data over like I have to do with Azure Blob Storage, I've got a smart compute engine over here, SQL Server or Oracle or Teradata or whatever. Just send the where clause this way, let it do the filtering, let it do the processing. It probably has appropriate indexes. It probably has well-designed structure. Let's pretend that it does. And it's going to send back the limited amount of data that we need for our query. So that's the idea behind pushdown. Almost always, you're going to want that thing to be on. There's rare cases where you'd want pushdown to be off. Mostly it's if pushdown is it's broken because an Odbc driver is buggy. That's about the only reason I've got. All right, so I've created an external data source. My next step is not create an external file format. It's an external table. The reason why is PolyBase v2, the Odbc stuff, doesn't need file formats. We're not reading from files. We're reading from Odbc sources, which are already structured data. We're essentially writing SQL statements against something that accepts SQL statements. So I don't need a file format because there's no file to read. I need an external table that matches exactly to my remote source. So if I actually say something like this, and I try to create this external table, first I'm going to open my master key just to make sure. But let's say I have ID blah, blah, blah. I try to create this external table. I'm going to get an error. The error says, hey, employee ID FD blah, blah, blah was not found in the external table. See, it has this thing called employee ID, and it's got a first name and it's got a last name. In other words, this structure has to match exactly. You need to match column names. You need to match data types, or at least have as something that can be implicitly converted. and nullability. What I wish they would allow you to do is say something like this, which you can't do. But basically, you know exactly what that structure is supposed to look like. You're telling me what the structure is supposed to look like because that's in the error message. Just create the thing for me. But unfortunately, doesn't do that. We do have to specify the column names. Now, one benefit to specifying the column names is if I don't need the first name, I can create the table like this and it'll work just fine. But let's say I do need the whole thing and I want to read the database forensic accounting, the employee table. And if I run this, I can query dbo.remote employee and it's going to hit my named instance and it's going to pull back data from that remote instance. So very similar to how a linked service operates, except that it's two-part naming and that the security is going to be a bit different between the two. So you can grant access separately for this external object in PolyBase versus a linked server. We can also connect to other sources. Here's an example with Cosmos DB. Cosmos DB, there are 5 separate APIs that are available for Cosmos. And the 2 that we're going to care about are first the MongoDB API, second the Core API. Core API is probably 95+% of all Cosmos DB installations. MongoDB is second or third most popular of their APIs. So let's create this. We do need a Cosmos DB credential. That is your account name, your username for the account, and the password for the Cosmos DB account. We are going to connect to the MongoDB protocol and cspolybase.mongo.cosmos.azure.com on port 10255. We have to send in connection options SSL equals true to force SSL. We have a credential Cosmos credential, and let's run that. So we've created an external data source, and I've got an external table, Volcano. No file format, because again, this is data that's not in flat files anymore. It's in Cosmos DB, a semi-structured database that I need to bring over to this very structured SQL Server. The data source will be Cosmos DB. The location is a collection on there called PolyBase test and a Volcano table. This Volcano table I created that in a way that is pretty well the same structure for every row. So we've got some details about volcanoes, including coordinates. The coordinates is actually an array in Cosmos DB of latitude, comma, longitude. And if I select star from volcano, we're going to see 2 rows for each volcano. And the reason is that SQL Server flattens my array and turns volcano coordinates into a float where one of these is longitude and one of these is latitude. So if I don't want that, I could say distinct and not include the coordinates. And doing this will give me back 1 row per volcano, but does not include the coordinates. If I wanted to include the coordinates, I could use string ag and bring them back together. And I've got my coordinates over here as a pairing. So linked servers do have the ability to do execute at, where you can run something on the remote side. Do we have a similar capability with PolyBase? No, PolyBase is intended to, it doesn't allow you to run stored procedures. It doesn't allow you to push a lot of work over onto the other side. And it doesn't allow you to send local data over to the remote instance. So if I have a small local table and I have a big remote table, with linked servers, you have the optimizer has the option to take the data that's on the remote, the local side, send it over to the remote side, and have the join operation occur over there. PolyBase is one way only, so it never sends data over. It only takes data from remote, and is only for select operations. So no execution of procedures So you couldn't say execute stored procedure from the remote side. You can put inside a stored procedure on your local instance, select from remote table, but you can't execute a remote stored procedure via PolyBase. So it's a virtual table. It's not a virtual SQL Server instance. That is what a linked server would give you. And I can also create a table that just doesn't have the coordinates at all. Like I mentioned, you don't need to have all of the columns in your remote source to be brought over to your local source. So in this case, if I create external table volcano2 without that column, and I select start from volcano2, I do not get the duplication because we just don't have that column at all. That's one way to access Cosmos. That's through the MongoDB API. There is also the core API. In order to work with the core API, you do need an Odbc driver installed. And I do have the Odbc driver here. This is the Microsoft Azure Documentdb Odbc driver. And that was released in 2019, back when it was still Documentdb or was being renamed. If you've got that driver installed, then you can connect using the Odbc protocol. So Odbc connect to my CS PolyBase core. So my Mongo instance will not support this driver. The different APIs in Cosmos, you create one account and it's tied to one API. So that means you can't have sometimes connect through Mongo, sometimes connect through core on that account. It's one or the other. So I have a different Cosmos DB that that's core. And I'm going to use Odbc, and I'm going to use the driver as the Microsoft Azure Documentdb Odbc driver. This name has to be exactly what it indicates. And here's my host, my authentication key. You could paste that in, and let's go ahead and run this because I want to select star from sys.external data sources. This is a DMV that allows you to see information from external data sources. And somebody who's connecting, oh, you know what? Actually, I have that already. So I need to drop it first. There we go. Cosmos Core. My location is Odbc, and my connection options, if I scroll over to the right, oh, let's keep going. Let's keep going. We got to drag it just a little bit further because I'm going to show you something that is really not great. And that is that your authentication key would be in plain text. That is your special key that prevents people from doing bad things to your Cosmos DB. Not something that you want in plain text in SQL Server. So let's not do it that way. The proper way to work with this is that if we go back to Odbc data sources, we can create a system DSN. That system DSN has the access key. This is your special key that keeps people from doing bad things to your SQL Server or to your Cosmos instance. And I can create an external data source with a location of whatever. I don't actually need the name. Only the word Odbc is relevant here. Like this, once you have this protocol, just whatever name you put in here doesn't matter because the connection options is going to tell where PolyBase needs to look in order to perform this operation. So I have a core table called employee. I've got first names and last names over there, and I can create my external data source. There is a comment in the driver that says that it doesn't support aggregate pushdowns, but I just wanted to show here that all of the queries that I've got here, these are simple queries against a small table, so maybe something is broken elsewhere, but all of these queries will work. And there we go. I'm running the serverless version of Cosmos for this to save some money, so it takes a moment for the first query to start up. But you know, I've got my names, I've got my aggregates, I've got aggregations here with filters. It all works. I haven't dug into this too much, so something is probably going to fail with this driver, but my simple testing said, yeah, I can do things that work. We have plenty of other options. I have a Postgres option we could go through. I have an Excel option. Excel is an interesting one, I think, because it also uses ODBC. This one uses the Microsoft Access Redistributable driver, specifically the 2016 version. And I can set the driver, and again, it has to be exactly how the driver name shows up in ODBC connections, including all of these things in parentheses. And I specify a file name. So I can read from a specific file, North Carolina population.xlsx. One thing I want to point out, I don't have Excel on here. I don't have Microsoft Office installed on this VM. The only thing I've got is that driver. And I can create an external table. I can read from this and be able to read data from my Excel file without having Office installed on the machine. So you don't have to install Office on your SQL Server in order to read Office. You just need that redistributable driver. And there was a question that had come up on Twitter a while ago about flat files, reading flat files. And technically you can do that with the Access Redistributable because it comes with a text driver that allows you to read external tables. Here I've got a CSV that is local, and I can run this. Now I have noticed a problem lately where I have like too many client tasks. I don't know what's going on with that with this driver, but I guess I got to stop using that demo because it's goofing up so much. But as a demo, it does work. If I just got to figure out what's up with this driver. So if you have an ODBC driver that allows you to read a file locally, you can make that available as an external table through PolyBase. It's not the only way that you're going to be able to access local files, but it's a way. I've got about 5 minutes left, so I want to show off one cool use case for PolyBase, and that is cold storage. The idea of cold storage is I want to make accessible older data without having to store it on my really expensive all-flash arrays in production. So I've got a table, fire incidents. This fire incidents is about 200,000 or so times that people have called the Raleigh, North Carolina Fire Department, and the fire department has been dispatched. They've gone out, they've had to do something. Just to confirm, it is not the Microsoft ACE OLADB provider. In this case, no, it's ODBC. OLADB is not going to be supported for PolyBase, only ODBC. So I have a blob here, Azure Blob Storage. I've got my visits on CS PolyBase Blob. And one thing that I do need to do for this demo to work is I need to go to the Storage Explorer and I need to delete, if I have any, the older versions of this demo. So let me very quickly pop into my Azure Storage Explorer. I think I can drag like that much over so that you can see. And I just need to find which account this is under. Here we go, CS PolyBase Blob. So inside here, I've got a container. Just got to load up the containers. Visits. In my visits container, I already have stuff in demo, so let's delete those. You know what? I don't want soft delete. I just want real delete. All right. So as this is getting deleted, we can see that things are getting deleted. Nothing up my sleeves. And popping back here, I'm going to read from that same account and that same container. And then I'm going to create some local tables. Let's say that we're interested in SQL Server holding the 2022 data as well as the 2021 data. And what I'm going to do is I'll add check constraints so that each table is has its own dispatch date time limits. And I also have one for nulls. And I'm going to load each table locally. So I could say 2022, and we've got data in here for 2022, 11,996 rows. Next step, we are going to create the blob storage, the external data sources and external tables. So we've got the external data source. Now we just need a bunch of tables. And I'll do this in a while loop and say that if it's not null, if we have an external table already, go ahead and drop it. And then I'll use Parquet, because when writing, we can only use Parquet and formatted text or delimited text. We cannot use ORC. ORC is not supported for writing in PolyBase in data virtualization with 2022. So Parquet file format, and for each table, we're going to create an external table, dbo.fireincidence year, in Azure Fire Incidence Blob for that year, and we're going to create external table as, or CETAS. This is how you'll be able to write data into Blob storage, Data Lake storage, or S3 using SQL Server 2022. Only works for those sources for that new data virtualization, does not work for the ODBC-based versions. But I have a filter where dispatch year is equal to year, and we'll go ahead and run this, and it's going to take a few seconds to run. While it's doing that, we're also going to create a view that unions together all of these. So basically that SQL Server 2000 partitioning style, we can use that with PolyBase. Yep, everything's done. And create a view that includes data from all of those different years. And if I just want local data, I've got the actual plan running so that I can see what my actual plan looks like. I have a table scan of 2021, a table scan of 2022, and concatenate them together. If I want to read from just a blob, it's going to show as a remote query, remote scan in this case. And if I want to combine the two, I can have read from the blob or read from local table, remote scan, table scan, combine the data together. So from the end user standpoint, these queries, it's just a query. There's nothing special about the SQL. From the standpoint of performance, it will be a lot slower because you have to read all the data from Azure Blob storage. So had a lot in here on scenarios and such that we talked through. And I want to say that SQL Server 2022, it's a pretty big update to data virtualization. There's still ODBC-based PolyBase. We're adding in APIs as well. Data virtualization, it's got some good business cases, but it will not give you the greatest performance. I guarantee you that much. If you do want a unified SQL interface, though, and performance isn't a top consideration, then it does a pretty good job of it. If you do want to learn more, if you want to grab the code, if you want to get the slides, if you want links to additional resources, that's csmore.info/on/polybase. And if you want to reach out to me afterwards, there is my email address. Every once in a while, I'm on Twitter. And with that, because we're at the top of the hour, I want to say thank you so much. Hope you enjoyed and learned a couple things.
I know I certainly did, Kevin. So thank you very much for all of this goodness. I do not see anyone having. Oh, I did see one final question from Yitzhak. Wanted to confirm that it is not using the Microsoft ACE OLADB provider for Excel.
Right. It's using ODBC drivers.
I thought so. Just wanted to make sure of that. So with that, since there are no more questions, and like Kevin said, we are at the top of the hour, I do want to thank everyone for coming. And be sure to watch out for this on DBA FunTube in the next couple of days, so you can watch it and try to figure out everything that's going on. Because, like Kevin said, there is a lot of stuff going on here. So, with that, I do thank you, Kevin, for all of this goodness, and we will talk to y'all next time.
All right, thank you.